What's up everybody? In this video we're going to talk about multivariate distributions and some typical problems that you may get. The first thing to notice is the name that you have for each of the columns and rows. And sometimes you might see this one, let's say a letter A. You might see it as X, sometimes you might see it as Y, sometimes you might see it as actually a name. It's important for you to know how to do this properly, because otherwise you have different letters, you might have a different association, and this will equate to you solving the problem in the wrong way. How this works is as follows. So all you have on top, in order to calculate the marginal distributions, so all these come to the bottom. So what this means is whatever you have in this specific column, you just count it. You just sum these all up and you're going to get a number here. Same thing for this one, and this one. And for this one, it's the same thing, but to the right. And what I mean by this is everything that you have, you count it to this side. So you're going to sum this one, this one, this one, and this one. That's all it is. So it doesn't matter if they call this A, X, Y, Carol, Susan. It really doesn't matter, because if it is on top, it comes down and you sum these all up as columns. And this other one, it doesn't matter again if it's X, Y, or whatever the case might be. You count it to the right and you sum all these up, all these rows. So 1, 2, 3, and 4 rows. So let's do that then. Here's how this works. So capital A is equal to little a. And then you have 0, 1, 2, and 3. And on the bottom, you have the function. So P of big A is equal to little a. And then you're going to have a sum of all these values. So 6 plus 24, so it's 12 plus 12. So 6 plus 24, that's 30, plus 10 is 40. Do these for the other ones. So 5 plus 8 is 13, plus 5 is 18, plus 10 is 28. So 0.28. And you're going to do this for the other one. So this one is 19, and this one is 13. And now we're going to do the same thing for these ones. So for it's same thing, it's big B equals small b, and then on the bottom you have the function P of big B equal to small b. Again, it's 0, 1, 2, and 3. It's just going to sum all these up together. So it's 18, the first one. The second is 28. The third one is 27. And this one is the same. So we're done with the first exercise, where we have the marginal distributions of both A and B. Again, I cannot emphasize this enough, because you will see this a lot in exams. So you must have always, at all time, the clear idea how this works. The one on the top, so goes down. So you sum all these up here, 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 and here. And the one on the left, you sum these all up. So all these rows to get all these 4 values. That's all it is. So we're done with the first exercise. For the second one, we are asked the probability of B given that A equals 2. So what this means is, if it's given A equal 2, we are essentially kind of locking in this column, and we are trying to find all the values like in rows, but just for this column. And the way for us to do this is as follows. So let me write this here down, and it's as follows. So we're going to use the marginal distribution from the column 2, which we already know it's 19. We have it here. And now we're going to do the same as we have here, but in a row form. So here's how this works. So the probability of B given A equals 2. Again, 0, 1, 2, and 3. And then we are going to have here the values, but for each one. So we're going to have 0.04 divided by 0.19. And I'm going to do the same thing for the other ones. 0.05 divided by 0.19. Same thing for these ones. These are the same. So essentially what we are doing here, taking the marginal value from this column, column number 2, and applying it to each one of the values. And on top, if they ask you, let's say, what's the probability of, instead of B, probability of 0 given that A is equal to 2, So essentially, you're going to take this value from b, so b equals 0. It's this one over the marginal distribution value that we found. For the last problem, we are asked to find the probability of A equals B. And this is actually pretty straightforward because when you think about it, it's essentially a diagonal. It's 0 equals 0, so it's this one. 1 equals 1, it's this one. And you do the same thing for each one of those ones that we are left off with. So it's this one and this one. So essentially, asking you all these ones. So this is essentially summing all these values up. So the probability of A equals B is the same as 0.06 plus 0.08 plus 0.05 plus 0.02, which is the same as saying that this is equal to 0.21.